Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about the National Quantum Mission, a mission launched by the government of India. And we are talking about this mission because a report has come out recently where a comparison has been made between the quantum missions of India, the steps government of India has taken in the field of quantum mechanics, quantum computing, and how it compares and fares with other countries, especially US and China. So where does India stand? That is what we are going to discuss in this particular video. So first of all, to give you the brief context, that recently National Quantum Mission was news because an organization by the name of Itihasa Research and Digital has come up with a new report. And as per this new report, it has surveyed the existing capabilities of the country in the area of quantum computing, quantum mechanics, and it has found that if you compare India with countries such as China and US, there is a huge head start. States have huge head starts over India, and in one way, can say India is still faring and lagging behind. Now, as far as India is concerned, it launched National Quantum Mission almost 1 year ago in year 2023, and actually it became one of the few countries in the world to have a dedicated program to harness the power of quantum technologies. But despite having a fairly strong research base that India has in quantum mechanics, quantum sciences, India has a lot of catching up to do if it wants to compete globally with countries such as China and India. So where does the difference lie? If you look at the report and the highlights of the report, it highlights the differences in three major areas. First, obviously, is the capital deployment. If you talk about countries such as China and US, they have invested a much more higher amount of money in the funding research and development in this field as compared to India. We'll look at the data also in the coming slides. Second difference largely lies in the dedicated human resource pool that India has toward the quantum field. And here in this case, more people are working in the sector in China and US, obviously, as compared to India. And third is if you look at the output of the programs, that means we can measure it on the basis of research papers published as well as the patents granted. In this case also, they have been publishing far greater number of scientific papers and have registered many more patents if you compare that with India. So human resources, the amount of capital invested, as well as the research and patent, these are three areas on which India is lagging behind. However, on the positive note, the report also has highlighted that Indian science leaders have been emphasizing that India is not exactly starting from zero. And in fact, in some areas, Indian scientists are very much at the forefront of the global research in the field of quantum physics, and that is something we need to celebrate and need to be proud of. However, if you look at the data to understand the differences more clearly, these are the data as we can see from here. So if you compare the investment made by India, India has made a total investment of $0.75 billion for the quantum sciences, where China has made about $15 billion, US has made about $3.75 billion, and European Union collectively also has made about $1.1 billion. Similarly, if you look at the paper published, India has published only 1,711 papers, and there you can see a stark difference. If you compare especially with US and China, they have published more than 10,000 of paper together. That means we can say 7 to 8 times more number of papers have been published. Patents also, look at China. China has been granted more than 23,000 patents compared to abysmally low number of 339 in India, and even in USA the number stands at only 8,935. That means Chinese scientists are able to get much more greater number of patients. If you compare in terms of the quantum of differences, we can see the difference is almost 70 times than the India. Similarly, number of graduate students, here India is much more better placed because total 82,000 students are graduating in related fields related to quantum sciences. In China only 57,000, in US only 45,000, and obviously European Union it has more number of 135,000. So what we can understand from there, that in the coming decade, when these graduate students start working in the area of quantum mechanics, quantum sciences, obviously the number of patents as well as the number of papers, research paper published is expected to soar significantly higher, and then India might be able to catch up with these other countries as well. Now, let us try to understand in brief about what is the quantum mission. Now, the quantum mission is related to quantum sciences. And in simple terms, quantum sciences can be understood as a science of subatomic level. That means when you try to study the atoms at subatomic level, when you try to study about electrons, proton, neutrons, and even below this sizes, below these scales, then that is referred as quantum science. So quantum mission largely is focused on building capabilities in quantum related sciences as well as technologies. Technology is nothing but the application of scientific concepts. And mission of India focuses upon 4 key domains. The first is computing, second is quantum communications, third is development of quantum sensors, and fourth is development of quantum materials. Now, the principle behind entire this quantum sciences development is matter behaves in very unexpected and counterintuitive manner in its smallest scale. Subatomic particles such as electrons seemingly exist at multiple locations at the same time, which is also referred as the principle of superposition. And this is something that scientists are trying to use it for their advantage. And quantum encryption is also largely based on the same concept, because electrons can exist at multiple locations at the same time, and this can play a very big role in encrypting or sending encrypted messages, especially based on quantum encryption. And it can influence the behavior of like particle with which they had a prior interaction over infinitely large distances. So that is what also we can understand is how quantum communication is possible. Also, quantum communication will be much more instant as compared to modern day or present day communication. So these are the, what we can say, future in which quantum mechanics will play a very important role. So if you look at the significance of this project, obviously it is only in the recent years that scientists have acquired capabilities to put them to some beneficial uses. Theoretical understanding of this quantum sciences, quantum mechanics goes long time ago, but practical application, practical capabilities to use and understand it has developed very recently. And one of the most important principle, as we have discussed, is principle of superposition. And this principle of superposition, where a atom or electron subatoms, subatomic particles such as electrons can exist at 2 places simultaneously at the same time, it can be used to perform real life tasks that conventional technologies are unable to achieve. So it will be a leap bound development, or we can say a stark difference between the modern day sciences and the quantum based sciences. Second, if we are able to harness this technology, we also may be able to do quantum computing, and the mature quantum computers, the ones they are fully developed, they would be able to do calculations that would be either impossible for the present day normal computers or would take far too long to perform. And that is where the capabilities of the supercomputers that are based on the modern technologies can be enhanced multifold times. Apart from this, it will also lead to develop, or we can say it will usher an era of new economy, because by overcoming the limits of current technologies, a quantum enabled transformation can build the foundation of a new economy in a decade or two, where the big data can be analyzed, the large scale analysis can be done, where you combine quantum computing with the artificial intelligence. Development is happening in both this field. So obviously, if you go ahead 30-40 years, the world will look very different. The economy will look very different as compared to present time. This is why India wants to try and rapidly build this capability in these areas, especially in the context that India is expected to become the world's third largest economy by year 2047. Now, if we talk about the major findings of the report, apart from what we have discussed about quantum computing and quantum mechanics, it said that rupees 6,000 crore, that is around $0.75 billion, that has been earmarked in India. It looks a large sum of money if you look at it in the Indian context, but in comparison to what other countries are spending, especially in US, China, European Union, these figure is very low, and for quantum related research, more funding is required. Funding so at least be 4 to 5 times greater, higher amount of funding has been expected. Among the 10% most cited paper, if you talk about US and China, again lead the way, and India just ranks 28th in the number of papers. India was ranked 9th if we talk about the number of patents that has been obtained in the field of quantum sciences, and the country was lagging on few other parameters as well, but it had a foundation that could be built upon given the number of graduates who are studying in the field of quantum science and related areas. So key takeaways, if you try to understand, that we can take from this particular report is that between 110 to 145 senior scientists are currently leading research groups on quantum related technologies in India, which is significantly good number. Outside the European Union, India had the largest number of graduate students in disciplines aligned to quantum technologies. As we have discussed, India has roughly 80,000 students graduating in the related areas, and European Union has around 112,000. National Quantum Mission needed to identify and promote young talent, and the mission could also raise a separate cadre of quantum scientists like the atomic energy or space science establishments had done. Because if you talk about the atomic energy, obviously you have a special dedicated this Bhabha Atomic Research Center is there. Apart from that, you have for space sciences, you have Indian Institute of Space Technology is there. So similar kind of colleges and universities can also be developed, which will cater to the field of quantum sciences, and people can graduate there and start working directly in the field of quantum sciences. So these steps, if taken, will go a long way in bringing India to the forefront of development, the cutting edge development that is happening in the field of quantum science, quantum technology, quantum computing. That is all for this particular video. Thank you very much.